Algebra 2, Chapter 13.2, Exercises 11 through 16. State the domain and range of the given function, then identify the new values of the reference points and the asymptote. Use these values to graph the function. Now, for our first problem, I don't like these instructions at all. Well, it's part of them anyway. What happens is we have this value of 3 here. This is called the base is equal to 3. And so basically we're starting with a function with base 3 is going to be f of x equals 3 to the power of x. So that's going to be sort of our parent function, if you want to call it that. And then here we have this value of 2, which is a is equal to 2, which indicates our vertical stretch or compression. Here we have this in the exponent here as 3 to the power of x plus 2. Well, here we have h is equal to negative 2, because to get x plus 2 we have to have x minus negative 2. And here we have this minus 1 is the k value is equal to negative 1. So what we're going to do when we talk about reference points is look at this original, if we want to call it our parent function, and graph that first, and the reference points are going to be taken from this. I want to put here x, f of x. So if we put 3 to the power of x, if we put in a 0, and so 3 to the power of 0 is 1, and if we put in a value of 1, we get 3 to the power of 1 is 3. And so the parent function is going to be 0, 1, and 1, 3. And so these will be our reference points that we're going to transform to create the graph of this function. Now let's see what we're going to do here. We are going to, this is this a equals 2, this is vertical stretch by a factor of 2. Okay, this one here, h equals negative 2. This is translation 2 units to the left. Okay, this k equals negative 1. This is a translation 1 unit down. And this becomes key because what it is, this will indicate our new horizontal asymptote. So if we draw down here, this is going to be y equals negative 1. So it says, I'm going to put the asymptote first. So I'm going to put horizontal asymptote, y equals negative 1. Okay, so that's one of our answers here. And let's go ahead and find the new reflected point. So what we're going to do first is we're stretching by a factor of 2. And so what I'm going to do is take this 0, 1, and I'm going to go ahead and multiply by 2. Let me see if I can, it's kind of awkward here. Let me see if I can go ahead and get this all taken over here a little bit. Yeah. just make a little more room. So what we're going to do is take, if we take this by a factor of 2, we're going to say h of x, and it's going to be so we have, multiply 1 by 2, we'll get 2, 3 by 2, we'll get 6. And so we're going to take these points and move them up. I'm going to use red for my translation here, just because it'll make it easier to keep track of. So we have 0, 2, and 1, 6. So that's going to be with our vertical stretch. Now we have our translations. We have 2 units to the left. So I'm going to take this 2 units to the left and 1 unit down. So we have this. And then we take this other point here. We take this 2 units to the left and 1 unit down. And what this becomes is like our new, we go to the left, that's our new changed y-intercept, if you'd have it. So these are our 2 new points. Let's see, we went actually 0, 1, so 1 went down. Yeah, we took this. So this one became this, and this point here became this one. So we'll say 0, 1 0, 1 becomes we have this 0, 1 stretched up here and moved down. We're going to have negative 2, 1. And then this other one here, 1, 3, becomes okay, we stretched it here, then moved it left 2 and down 1, so that became negative 1, 5. So those are going to be our new reference points, and then use the values to graph the function. So we're going to come like this. I don't know what it's going to look exactly like to the left, but it's going to come this asymptote here. So things are going to look something like this. So let's see if there's anything else. Yeah, domain and range. Okay, domain is going to be all real numbers, which is going to be the same for all exponential functions. Our range is going to be greater than our new horizontal asymptote, so greater than negative 1 and less than infinity. And so these are all the values. Okay, let's go to the next odd number problem. Here we have on problem 12, we have a negative sign, which is going to involve a reflection about the x-axis. So let's go and do number 13. And I'm going to take our basic parent function here. We have our base of 6. So I'm going to put here f of x equals 6 to the power of x. So here we have a is equal to 3, which is a vertical stretch. By factor of 3. We have h is equal to 7, h is equal to 7. So that's going to be translation 7 units to the right. And k is equal to -8, which is translation 8 units down. Okay, so now our basic function we're going to graph here is x and then f of x. And we're going to use 0 and 1 for our reference points. And if we plug in 0, we get 6 to the power of 0, which is 1. If we plug in 1, we get 6 to the power of 1, which is 6. So we get 0, 1. That's our first reference point. Our second one is 1, 6. Now we're going to change things here. What are we going to do? Well, the first thing I'm going to do is stretch by a factor of 3. So I'm going to take these points one at a time. So I'll put 0, 1. Let me just go ahead and sketch. The graph's going to look like this. I'm going to erase it really quickly, but the graph of the original is going to look like this. Okay, that's what the graph of the original is going to look like. Stretch by factor 6, by 3, excuse me, stretch by factor 3, that's going to be 0, 3. Okay, and if we take the next point, 1, 6, stretch by a factor of 3, that's going to be 1, 18. All right. Now next, so this is going to be the vertical stretch. Now we're going to do the horizontal translation. What we're going to have is, I'm going to put it horizontal. Okay, horizontal translation. That's going to be, we're moving 7 units to the right, so 0 plus 7 is going to be 7, 3. Okay, and this 1, 18 is going to be 1 plus 7, or 8, 18. Okay, and the last thing we're going to do is take our vertical translation, which is 8 units down, so what we're going to do is take 7, and 3 minus 8 is going to be -5. And now for this last one, we have 8, 18 becomes 8, 18 minus 8, so that's going to be 10. So we have, I'm going to switch to red now, and marking our answers. So we have our k equals -8, that's going to be our horizontal asymptote. K equals -8, or y equals -8, rather, I'll put the value k. Y equals -8. We have the new points 7, comma, -5. So here's 7 to the right. These are going by 2 and 5 down. 2, 4, 5. And then the next one we have is 8, comma, 10. So we go to the right 8 and up 10. So right here. And so our graph is going to look like this. Very sharp upswing like this. So that's basically what it's going to look like. So let's write our answers here. Horizontal asymptote. Y equals -8. Okay. Reference points. 0, comma 1 becomes 7, comma, -5. And 1, comma, 6 becomes 8, comma, 10. Okay, domain is going to be in interval notation, all real numbers. And our range is going to be from our horizontal asymptote up, which is going to be -8, comma, infinity. Now the book uses set notation. I like interval notation better. I think it's more economical, and it segues better into pre-calculus and calculus. So I think that's it. Let's go to next on the problem 15, which I like. It's a good one in that it does have a negative number here. Let's go back to the blue. So basically what we have is I want to take the blue here. There we go. Basically what we have here is A is equal to -1/4. H is equal to, we have x plus 1. So that's going to be x is equal to, we'll have x minus -1. So h is equal to -1. And k is equal to -3/4. So that's going to be, right, I'm just going to write that equation here. So y equals -3/4. That is going to be our horizontal asymptote. Okay, let's go ahead and take what we have here basically is we're going to go from f of x equals our base of 5 to the power of x. So if we go to h of x, or x, f of x, and we plug in 0, we get an output of 1, because 5 to the 0 is 1. If we plug in 1, we get 5 to the power of 1, which is 5. So our original points here are going to be 0, 1, and 1, 5. Now, let's go ahead and take our reference points and select them. So we have 0, 1. Let me move this down a little bit. There we go. 0, 1. The first thing we're going to do is reflect, or take the negative sign and reflect it about the x-axis. So we'll call this reflection about x-axis. So what we're going to have is 0, -1. And the next thing we're going to do is we're going to compress by factor of 1/4. I'll put 0.25. Just make it easy. So we're going to have 0, we multiply this by 0.25. We're going to get negative 0.25. Okay, next we're going to horizontally translate by 1. So that's going to be, we're going to take 0 plus 1, and all right, minus 1, h is minus 1. So we're going to have negative 1, negative 0.25. And the last thing we're going to do is vertically translate. And so we're going to, this k is negative 3/4. So what we're going to do is add negative 3/4 to negative 0.25. Well, negative 3/4 plus negative 0.25 is going to be negative 1. So there we have it. That's going to be our first transformation. The next one we're going to have is 1, 5. And we're going to reflect about the x-axis. So that's going to be 0, negative 5. Next, we're going to compress by a factor of 0.25. So we have 0, and we multiply by 0.25. We're going to get 1.25, right? Or negative 1.25. Because of a half of negative 5 is negative 2.5. A half of that, again, is going to be negative 1.25. Okay. And next, the horizontal translation. We're going to take, oops, I need to fix my values here because these things are supposed to be 1, right? And 1, 1. Okay, we haven't changed the x values at all. Okay, 1, negative 5. We Let me write that a little more legibly if I can. 1 comma negative 5. You have 1 comma negative 1.25. We horizontally translate, which will be subtracting 1. So we're going to get 0 comma negative 1.25. And the last thing we're going to do is vertically translate, which is changing this negative 1.25. And we're going to subtract 3/4. So we're going to get negative 2. So now I'm going to write these, do these rest of this in red. And so we're going to have is negative 1, negative 1, so right here. And then we're going to have 0 comma negative 2. So what this is going to look like is this when we graph it. Let's see if I can get this a little more accurately. Something like this. Okay, so let's go ahead and write our answers. Our horizontal asymptote, y equals negative 3/4. We have the point 0 comma 1 becomes negative 1 comma negative 1. We have 1 comma 5 becomes zero comma negative 2. Our domain is going to be all real numbers. Our range is going to be, now we're going from negative infinity, so we're going to go from, a range starts from the lower values, from greater than negative infinity up to, but not including, negative 3/4. So really, that's what there is to it here. And these are our answers. Okay, and then number 16, which I'm not going to plan to go over here, you do the same type of thing. You'll take this f of x, take an f of x, and have that be 4 to the x, and then do all the transformations like we did in 11, 13, and 15. So really, that's it. I hope this has been helpful to you. Good luck, and thanks for viewing.